What's happening, guys? Thanks for stopping back by the channel today, here at the Rust Belt Mechanic. So we've got something really amazing to be able to show you. We are up here at North Prairie, Wisconsin with the guys here at Kodiak Driveline. There's a little Mark in the background, the master of the driveline specialist here. We have got ourselves a 2001 Duramax that we're going to be doing a little bit of custom axle work to it today. It does have some custom axle already done. We've got a govlock that is already in this thing, and we're actually going to be putting an AAM True Lock Tracrite. We get that one right. We're putting a Tracrite, taking the old unit out of this one, putting some special Yukon axles into it, going through the whole rear end, the diff process on this one. It'll be a great one. Stay tuned. Now I know I also did a video also before on changing my two-piece drive shaft over to a one-piece drive shaft. This truck we are also going to be doing that one also, which is going to be nice for a lot of the questions that I get quite often is part numbers and everything that's used. This is a quad cab short bed, whereas mine was a quad cab long bed, so I got the part numbers for that one, and we're going to have the part numbers to do this one as well. We've got one of the one-piece aluminum drive shafts from GM sitting right here. We're also going to be doing a 1480 little accessory right here for the pinion. We're going to be putting that one on top of it after we do the whole axle build too. So we're going to be putting part numbers down in the description. I'll get a couple of pictures for it as well.
Dude,
now for only having 2,500 miles, that's some pretty nasty fluid there, Beard.
So
like,
we could say that
sure?
We could say that it's worse.
It does look pretty gross.
No, that's your govlock already coming unhinged.
So if you guys aren't very adept here to what we're looking at, this is one of the govlock designs. GM is notorious for using these, and they're also notorious for not being able to take a whole lot of horsepower or torque numbers to them. And as Beard can attest, he really puts the we'll say the go beans to this thing. So we're going to be making this thing a whole lot more beefy today by putting the other gear housing into this one, getting rid of this govlock, making it a lot more beefy today. Now these are pretty simple to be coming apart. It's just I'm not a big fan of these design because there's a whole lot of parts and a whole lot of moving things to go wrong, and you guys can see all the little tiny splines and gears that has to go into the inner workings of these for the whole track lock. It's just not, the govlock system is just not a great design when it comes to beefiness. So let's get this thing pulled out and we'll see what we're getting into. Tell you one thing I'm going to be stealing is this idea for whatever confangled contraption you got going on here that fits right onto a rotor and catches all the grease oil instead of coming out all over the floor. You guys take a look at that one. It's not meant for this, but it damn sure works. That's really cool. Do you work out, Mark?
Every day. Here.
That's working out. We're removing the pinion out of here because we're going to be upgrading to the new 1480 so we can get the bigger U-joints for this better unit. Gonna end up working out better, handle more horsepower. Everybody likes horsepower, right? So here, once we got everything out of this AAM housing, you can see the inner workings. He's working on putting some new pinion seal in the front, and then here we've got our adjustment sleeves, which is threaded into either side. We got a special tool that's supposed to be able to kind of grip onto the outside rings to adjust in either side here to get our backlash set up correctly. I like these on the AAMs because it is so adjustable, easily done. You're not having to worry about shims, checking, rechecking. So easily adjustable. It's going to go really well for this setup. We're going to go up front and check out this new pinion and flange that he's putting in here. All right, so we got some red thread locker going on here. About how many Ugga-Duggas does this one get?
2.34 Ugga-Duggas, and it is good.
That's what I'm talking about. We do everything in Ugga-Duggas here. A little bit of Loctite on those.
No, yeah, normally that's half them down.
So what are we doing right now, Mark?
We're going to transfer this ring gear over onto the new carrier, and then we'll clean everything up, reassemble the ring gear on there, re-lock tight bolts on down on there, and then flush the housing, get that thoroughly flushed out, and then we'll reinstall the carrier and set backlash, check pattern, and put our alloy shafts in, and then finish up our one-piece shaft.
Now we are going to be reusing the ring gear on this one. We've got all the bolts loosened as we saw. We're going to be dropping that one out. What's the gear range on this one?
This is a 373.
373?
Yeah.
Yep, so we are going to be reusing the ring gear because obviously the pinion's still in there. Ring and pinion are matched up to each other, so we've got to get this one on. Looks like somebody had plenty of thread locker on there, making sure this little thing wasn't going to be coming apart anytime soon. So when you guys are changing out this rear pinion housing, so I guess normally when I do the rear pinion seals on these, what I like to do is I like to take a little chisel tap and I will tap in a line here on the actual pinion, a line on the nut, so I know exactly where to retighten these things to. For you guys who don't know how these things work, there's actually a crush sleeve between here, between the two bearings on the inside portion and on the pinion gear on the inside. So these need to be tightened down to a specific torque as to not over tighten the bearings. That crush sleeve is like a nice little pressure cap in between the two bearings to keep the correct amount of pressure on the inner and outer bearing on it. So when we're tightening this one down, we're going to tighten it down to right around 20 to 25 inch-pounds of turning torque on this one. The turning torque is what's key. Now, for these guys like Mark, who've been doing this for 20 plus years, these guys are able to just like, yep, that's the right amount, and they hit it 100% of the time. It's all by feel at this point. Yes, you can do it the technical way, but at the same time, you know, these guys know what they're doing.
We've got our govlock out, and you know, everybody knows the reputation of these units. It's not great. I've seen more fail than that have lived, and it's funny because some forums I go on and everybody says, oh, those things will take 1,200 horsepower. Maybe once. And we're going to upgrade. We're going to do the AAM style Tracrite. It's much like the Detroit Trac. A little less money. Quite honestly, in all the years I've installed these, I've never ever had one of these fail. We've got one of these in Ryan's pull truck that we actually pulled out of a used Dodge that had 265,000 miles on, and he has tortured the thing and can't break it. So I really do like these units. The only limitation is the biggest we can go is 30 splines. So we are going to do the 30 spline Yukon shavs in here. This is a used pair that the Beard had out of his pull truck after we switched it over to 38. So this should be a sweet little setup for a truck with a non-built motor. He's going to be making somewhere around 720 and just going to go have fun and drag race this thing. So it'll be a neat deal.
Now with these axles here, what's the big upgrade to these over the stock AAM axles?
Yeah, they rate these roughly at about 40% stronger than stock. So that's a good upgrade. Definitely. Obviously, once you get to that 900,000 horsepower range, you're flirting even with alloys at that point. You got to go up to the bigger 38 splines. But then your carrier choices are limited. A spool or a grizzly locker is your really only options at this point.
Other question on the new locker right here. What are you pulling this one out of? Normally this is what, a Dodge?
Yeah, the 11.5 AAM Dodge, this is their factory positive traction unit. And some people like them, some people hate them. The thing is knowing the unit and how to use it, and that might sound stupid, but the downside of this unit, and I'm going to say the only downside is if you have less than 5% traction to either tire in the rear, it'll act like an open. So at which point in time, the best thing to do is just lightly drag your foot on the brake, and it'll lock up and away you go. You're never going to have that situation, truck pulling, dirt dragging, any of that. Where this unit is going to give you grief, if you want to call it that, or not work the way you want it to, would probably be if you got your truck and you're out ice fishing on the lake for the day, and the sun comes out and it gets sloppy out there. That sort of situation, black ice might be a problem. But again, you know, those are extreme conditions, not normal conditions. You're only probably talking 1 or 2 times a year for that.
So for everyday driving, this one's going to need a little bit of drag to get it to grip on that one.
In those situations, yes. The positive is no clutches to wear out. Will act like an open going around the corner. You're going to have no clutch binding, no nothing, because it's a helical design unit. I really prefer the helical design units. I've used them for years. I love them. They're reliable. No posi additive. You put your gear oil in and you go. They work. It's an excellent design. The military had these in the Humvees. It's just a good design, period.
And compared to all these tiny little moving pieces,
the ones you usually find in the bottom of the housing?
Yeah.
Yep.
That's just crushed tinder in the bottom of your rear end. Yep, that's what that would be with 800 horsepower.
Obviously, our little gear here normally breaks these teeth off, takes all the teeth off the ramp plate. The ramp plate, I call it a ramp plate because that's exactly what it is. If you look at this, it goes back and forth. And this unit, when this gear drives that ramp plate, it turns it and it jams this side gear forward to lock the clutches up. And then Josh's battery goes dead. And what will happen is all these little teeth will come off then, and I've seen two, and it's quite common, where that ramp plate will break into numerous pieces. I've already had these break and jam that gear forward, and the unit was acting like a spool. It was locked all the time. I had a customer that swore his posi worked, and he proved it with a nice burnout in the parking lot before it came in, and yes, it did work, and it worked because literally everything was welded together at 280,000 miles. So the best thing you can do is, before this unit blows up, get it out, take it out, and replace it, because once this stuff blows up, it's going to wash through your ring and pinion, it's going to wash through all your bearings, and you'll end up rebuilding the entire complete differential, which is obviously a costly expense. So what ends up happening is your plug wells here that hold your tube into the center section, in a drag race application, truck pull, whatever, under load, it's going to want to take the pinion and roll it up, and the whole casting will roll up, and the plug wells will break. So we're going to come in here. Beard's already cleaned these up pretty good. We're going to preheat this. He's going to go around and weld both sides up on this, and that'll prevent any of that from happening.
So what's the point of preheating this one?
The cast housing to a mild steel tube. In order to weld on cast, you got to preheat it. You're supposed to use a specific wire. Wire is pretty expensive, so welding it with normal, like an E70 wire, is just, it'll work. It's not going to go anywhere. So between the factory plug welds and then welding the tubes, it just helps it hold together a little bit better.
Nice.
So, and being as thick as it is, preheating, you're more guaranteeing that you're going to get better penetration in your weld, so that it wasn't for nothing.
You're going to put a couple passes on there, Tyler?
Yeah, I'll probably triple pass it.
Yep. So we're going to pre-lube our bearings on our carrier. We got those all pressed on. We got our ring gear on. We got our bolts Loctited. We're going to take this unit and drop it in. Beard's going to assist me with main caps, sides respectively.
Gotcha.
And we're going to get this in there, dial in our backlash, adjust that, pattern this, and see what we got. First I got to get these adjusted. What I'll do sometimes is I'll push the carrier towards the pinion, the load side, grab the load side of the carrier and push it, and I'll bring the adjuster wheel up till a point that I can feel I start to get a little bit of backlash, and then I'll stop. And obviously it's not right yet, but it gives us a little starting point to get to. So right there, if you can hear that, we got a little bit of backlash. So now I'll just bring the other side up to that, get close, and then I'll fine tune it in a little bit from there. We'll get the caps on, and we should be good to go. Now I got way more backlash than what I like, so we're going to go ahead. We're going to take some out this side. We're going to shift the carrier over here and adjust this a little bit.
That's the cool thing about these AAMs. You guys can see, get a little zoom into this area. Those caps, they have little openings to them, and they are threaded on each side, so you can adjust this entire carrier one way or the other with just a couple of taps.
Now this isn't our final torque. We're just tightening this thing down in here real good. I like to always spin the carrier around a couple times before I even put any gear marking compound, and then go back and just check my backlash again and say, well, yep, I'm not there yet, I don't like it. We're going to tighten that up just a hair more. So we'll back these. At this point I'm happy with the preload I have on the bearings. But what I'm going to do now is, if I move this one hole mark, I'm going to move the other side one hole mark so I stay consistent. That way we maintain our preload and we're good.
So if you don't know what we're doing right here, we're going to be checking gear pattern just to see what our gear pattern is on these. A lot you can tell from how these rear ends are, I guess, keyed to each other. How the gear is driven is based on how they connect and touch each other. So we've put on a bunch of dye, essentially dye, to be able to tell the pattern of where they are actually touching between the pinion and the ring gear. Really what you want to see is a nice even stroke right in the middle of the gear side. You don't want to see it high on the land, high on either side to side. You want to see about dead nuts in the middle. So you can see right here, we are pretty close to the middle on this one.
Yeah, coast looks good. Our drive side, we're inboard, so we can adjust our pattern. We can bring that pattern out a little bit more simply by opening up the backlasher here. So I want to now go back after rolling this thing over a few times. We're going to open this backlash up a little bit. We're going to re-schmutz that with the brush, and we're going to see our new pattern and see where we're at.
One more adjustment to her, and we'll see how we're touching on our gear pattern now. So he's getting a good pattern going in each direction, one way there and on the back, so we can see, make sure our backlash is good.
So now we can see, and I'll use my pocket screwdriver to see, our pattern starting here, and we're walking out to about here. In a stock daily driver application, this will work, but you would want it more down the center. I purposely set my differentials up a little bit more inboard in a performance application, because under load, that pinion wants to shove this ring gear that direction. When that happens, this pattern's going to walk out. So if you do a textbook pattern down the middle, you take it out and pound on it, you're going to run off the end of the gear, you will blow the ring and pinion. People may argue that fact. I've never had an AAM blow up on me, ever. So, and these housings, believe it or not, you look at the size of this, the mass amount of metal, they will flex. Dana 80 housings generally don't flex. 80 housing is way more tougher than an AAM, but you know, they're not, when they were manufactured, they weren't meant to be put through what most of the guys put these things through. We're going to go ahead, though, and check our coast side. Our backlash is beautiful. I'm happy with the drive side. And Beard's truck here, believe it or not, this gear set has 310,000 miles on. And so this thing's been put through its paces already. And for 310,000, this gear set's set up really, really nice.
We've got the Yukon one-piece axles right here, alloy axles.
Yep.
Beasts.
Yep, our 30 spline, we put a new OE gasket in there. Don't like the idea of silicone. Can use it in an emergency, but usually guys end up putting too much silicone in there and they pack it in their wheel bearings and everything else. And
I highly agree with that one. Do not just use RTV for this gasket material. Some guys say you can. I have never had good luck with that one myself either. The other thing that you guys really need to make sure that you do on these AAM rear ends is to be able to get fluid to the outside ends to be able to get to the bearings on either side. So to be able to do that one, you can either move it outside if you have a really steep grade and kind of tilt the whole rear end one way or the other, or if you have it on a rack, just simply put a jack under one side and or the other. Usually it's best to put it up to a pretty decent angle, usually at which that full side is up as high as the suspension will allow it to go. Let it sit there for about 5 or 10 minutes to get the full amount of fluid into each of the bearing carriers on either end. You really want to make sure those things are lubricated really well, otherwise you will have rear end failure. You guys will go through your bearings on the outside carriers. So we're going fully technical here. We have to cut out the center support section right here for the one-piece drive shaft conversion, because that one-piece drive shaft is a whole lot more beefier than the two-piece one. So old Beard's gonna get the liquid saw out here and chop her off.
all right, on the 0102 short beds, if your truck didn't have a service bolting done from the factory, your truck had a two-piece drive shaft in it. If your truck has a one-piece aluminum now and it's an 0102, somebody took it back to the dealer and they did a service upgrade on it. We've got our 1480 yoke on, got our drive shaft with our 1480 joints, and Tyler's going to install it. It's ready to go.
Well, I'd say from that burnout, we had some success and the rear end holds just fine. Lighter drive shaft, I guess, helps with burnouts too, but all in all, excellent work.
Mexico now?
Well guys, that's about all we've got for you today in the way of this performance rear end build. If you guys like this kind of content, make sure you hit that thumbs up button and subscribe to the channel. Make sure you turn on the bell notification so you get notified when I come out with cool, awesome content just like this one for you guys to enjoy. Thanks for tuning in today, and as always, you guys stay awesome.